Hello, my name is Jason Cornelius. I'm an aerospace engineer at NASA Ames Research Center. I work partially on the Revolutionary Vertical Lift Technology Project and partially on Dragonfly, sending a helicopter to Saturn's moon Titan. So I grew up in a small town called Mountaintop, Pennsylvania. I got into engineering. We had a kind of program where it was a tech program, and one of the guys, he kind of was pushing engineering on us. And so decided I wanted to do that. I grew up about 2 hours away from Penn State University, so I decided to go there and do aerospace engineering. I went through my undergrad at Penn State and eventually stayed on and did master's and PhD all in aerospace. And early on during my time at Penn State, actually, I talked to Professor Ed Smith, who's the head of the VLRCO, the Vertical Lift Center at Penn State. And that's what kind of pulled me into helicopters, pulled me into VFS, and here I am some 10 years later. When I started at Penn State, so the aerospace program is pretty general. Once I got into the VLRCO, they have an emphasis on rotorcraft engineering. So the undergraduate curriculum at Penn State is pretty broad, covers everything like spacecraft and aircraft and helicopters even. The longer I was there, the more I got into vertical lift. So I did some research opportunities in the VLRCO, where I got engaged working actually with the local chapter, our student chapter of VFS, and did different opportunities looking at rotorcraft engineering and design. I had the opportunity to do some internships, so I went down to Bell Helicopter in Texas. I was out here at the NASA Ames Research Center as an intern, working in the VLRCO, so a lot of rotorcraft focused projects, even from early on, really starting my freshman year. Yeah, so when I was at Penn State, I started out pretty broad. I worked on a lot of different project teams. I had some interest in wind energy, so I was working on something called the Department of Energy's Collegiate Wind Competition, and as well the helicopter activities. And so what I found actually was that all these different projects that I was getting into, they were really revolving around rotary wing aerodynamics. And so I could have gone in a few different paths. I could have gone into the wind energy industry, working at something like NREL, go to a helicopter company, go to NASA. So there was quite a lot of choices in front of me, but I knew that the general focus was aerodynamics of rotating wings, essentially. So I landed out here at the NASA Ames Research Center, doing that kind of thing, so aerodynamic design and modeling and simulation for rotary wing vehicles and a lot of different kind of things along those lines. Okay. NASA has what's called the Revolutionary Vertical Lift Technology Project, RVLT. And so this is an organization within NASA, within the Aeronautics Mission Directorate. And so we work a lot on developing tools to advance the rotorcraft engineering field and help different industry companies to advance their designs as well. So a lot of what we focus on within RVLT is developing the methods and tools and applications that can be shared with the broader community. So we share these, and companies and private companies throughout the industry use some of the tools coming out of NASA in order to advance the product lines that they're trying to make and trying to bring to market. And so we're quite involved at this point with, of course, conventional rotorcraft design, but also the newer advanced air mobility and urban air mobility markets, getting into some things like disaster relief, emergency response, eVTOL vehicles. So it covers a pretty broad range of UAS and eVTOL applications, both in the US and globally for that matter. Now we're getting even into space, so going interstellar as well. When it comes to tools, we really have some that have been around for quite a long time. And so some of the tools that we use day to day to design rotorcraft, they're quite good at what they do, so there's no reason per se to replace them or create new ones. But the interesting thing is that lately we have the eVTOL kind of revolution, you might call it. So we have a lot of these new concept vehicles coming out, and they're a little bit of a different configuration than what's been your typical helicopter for the last several decades. So a lot of these eVTOL companies, they maybe have fixed pitch propellers, and so instead of having the full articulation where the blade can move around and do all these crazy things, you just have a fixed pitch propeller that's bolted onto a motor. And so we have kind of found ourselves in a position where we do need to have a little bit novel tool development to match the novel configurations that are being developed right now. Yeah, of course, NASA has been working on rotorcraft on Earth for a long time, and so have a lot of other folks. More recently, though, back in the late 1990s, there were some NASA researchers and some researchers around the country that proposed using airplanes and gliders and helicopters to advance our capabilities for exploring other planetary bodies in the solar system. So of course we've had Ingenuity on Mars that flew 72 flights, I believe it was. We have Dragonfly that's destined to go to Saturn's largest moon Titan and explore there. And so, 25 years ago, these were first being proposed as a means to enhance how well we can explore these other places. And we almost had to wait until the public perception was ready and as well the technology was ready to really prove that, hey, these kind of very advanced technical projects are actually something that we could conceivably do, pull off, and then send it out there, and it would be a good use of the money, the taxpayers' money. Yeah, when we get into things like designing rotorcraft for space, there are a lot of key differences between the different environments we go to in space versus how we might design a rotorcraft or a helicopter here on Earth. So for example, with Dragonfly, going to Saturn's moon Titan, the atmosphere on Titan is about 4 times denser than the air that we're standing in right now. The gravity is lower, and it's also cryogenic. So the atmosphere is 95 Kelvin. I believe that's about negative 300 degrees Fahrenheit. And so these things, they combine together to make it a real complex engineering challenge. I mean, there are some things that the conventional rotorcraft engineer on Earth has done it the same way for 100 years or a long, long time. And some of those approaches, they're not applicable when you get to Mars, when you get to Titan, when you get to planet X, Y, or Z. And so we have to come up sometimes with some creative solutions of how we can take what's been done for a long time and we know works, but adapt that and still try to use what's worked and what we've learned over the last several decades, but adapt it to new environments and still be successful on those environments. Yeah, when I was at Penn State, I got involved with the Vertical Flight Society, I want to say as a freshman probably at the time. So inside the Penn State Aerospace department, we have a few student organizations, VFS, AIAA, a lot of these typical ones. And so I kind of randomly reached out to one of the professors, the head of Penn State's VLRCO, and he put me in touch with some of the students that were running our local student chapter of VFS. So I got engaged with them, they brought me in, and I got to just interact with them and learn, hey, what are you guys doing? And they were at the graduate level, a lot of them. So I was a young student at the time, undergraduate, and I'm hearing from these graduate students what kind of research they're doing, what their interests are, why they decided to go into graduate school. And so it was really nice. I mean, it gave me a lot of different perspectives. And so then when the time came for me to choose between going to work in industry or staying on at Penn State or somewhere else for graduate school, I had this wealth of insight and expertise and maybe even experience, I guess, from their perspective of why they chose to do that. And yeah, it's been a pretty natural progression for me. So being involved with VFS really helped to steer what I ultimately decided to do with my career, I would say. Probably one of the bigger factors of how I ended up definitely within the rotorcraft community, and even leading to the PhD. So I would say if I hadn't gotten involved with the student chapter of VFS, I don't know if I would have done my PhD. Right, so within the Vertical Flight Society, I've had quite a lot of roles over the years. So when I was at Penn State in my undergrad, I was actually the vice president of our student chapter at one point. I did, a lot of outreach and volunteer activities with VFS, so we hosted a lot of events and things like that at Penn State. I did serve as the student representative to the Tech Council. So within VFS, of course, we have a Tech Council that kind of steers the forums and conferences, such as where we're at this week. And so I was involved with that for a while. I did stand up recently, 4 years ago, I think we started the Vertical Flight Society's Design Build Vertical Flight competition. And so this is modeled kind of similar to SAE Aero Design or AIAA Design Build Fly, where we get student teams from around the world that design, build, and then compete with a UAS eVTOL platform. So we have teams coming from all over the world. They come together and fly off against each other. And the whole point of the competition is to give the students an opportunity where they can get some hands-on engagement, designing and building a real platform that's fully integrated, and get some of that exposure, get some of that experience before they go into the workforce. So that's been a pretty big part of what I've been involved with. Of course, working at the conferences and helping out, presenting and sharing the research that I do at the VFS conferences is one of my favorite activities. The VFS DBVF competition has grown quite a lot over the years. We started out during COVID actually and had it be a virtual final competition. And then as we kind of got out of COVID, the student teams, we had a few teams, I think 3 the first year, that came to ARL in Maryland, and they flew off against each other there. The next year we had a couple more teams, and then this year we're up to 15 competing teams. So as of right now, we're planning to have 15 teams come to Service Engineering in Churchville, Maryland, to do the final fly-off against each other. So, the reach has been growing quite quickly, which is great because we're getting this opportunity for the students to get these hands-on experiences, designing these eVTOL UAS systems, and then also building some camaraderie. So you get the students together, you have professors from different schools, and it's a good way to kind of mix the rotorcraft community together and share things that they've learned and share experiences and maybe even some things of what not to do. And getting together, they can help each other to all advance towards a more skill set, better skill set for future UAS design. It's a challenging thing to get people into the rotorcraft field. You know, when you go into aerospace, you think about airplanes and rockets as the more typical kind of career path. And so something like helicopters and rotorcraft maybe isn't the first thing that students think about when they choose that they want to go into aerospace or mechanical or electrical engineering. I was fortunate enough to have the student chapter of VFS at my university. Mm-hmm. So for me, it was kind of a natural choice to get into that. But for students that are maybe coming from other places where they don't have that society set up already to support that choice, there are things like the student competitions that help out. But again, you know, you kind of need some support to even get that going. And so I think doing outreach activities is a really good one. So of course it would be hard to send VFS staff members per se to other universities and advertise the society and the rotorcraft field. But one of the things that I like to do, for me personally, I go to local universities where I live, and sometimes I do kind of pitch the student competitions or VFS in general, or even if I go and talk about what I do at NASA, what I do for my work, and then I give some plugs and say, hey, if you're interested in this, there's this entire society that you could join. Even if you don't have your own chapter, you can join online, follow along, get the magazine, and learn more about it.